What is up, YouTube? Welcome back to another episode on Code with Annie. And thank you so much for continuing to support the channel and providing your valuable feedback through the views. And I would really appreciate if I can get some comments as well, and so that I can know what topics you are also interested in, which I can make further videos on. But apart from that, let's take a look at the topic for today, which is going to be on a little bit of a deep dive into the list implementations, which is ArrayList and LinkedList. Okay, as I mentioned in the previous video, there was a small clarification that I want to make before I start. I mentioned that the linked list implements the DQ, right? So it's not the I would have mentioned as DQ operation. It's not the DQ operation. It's basically the double-ended queue. So because of the way I pronounced, the concept that came to my mind was completely different from what I wanted to explain. So it's called as DEQ, okay, DECK, right? As you pronounce DEQ, it's called as DEQ, and DEQUE is nothing but double-ended queue. What I mean by that is, it's a special queue wherein I can do the insertion operation from both sides of the queue, whether I want to insert element in the first or I want to insert element in the last. Same way I can remove element from the first or I can remove element from the last. Okay, a normal queue will have always insertions happening from the last and a removal happening from the first. Just like how you look at a real world queue, right? If you're gonna go and stand in a queue, right, you cannot go ahead and stand at the very first point of the queue, right? You will only stand at where the last person was already standing. You'll stand behind him or her, and as the queue moves, the very first person who's at the queue will be the one who will be removed from the queue first as soon as this process is over, right? That's the exact same way the queue works in Java world as well. And DQ is a special queue here because it's starting and ending point can be interchanged basically, and it can be data can be added to the queue on both sides and data can be removed from the queue on both sides. Now with this clarification in place, you can observe that linked list implements both the list interface as well as the queue interface, right? So I'll tell you the beauty of why this does this way and what is the benefit of linked list having both these implementations, whereas ArrayList does not have this, right? Let me show you an example. Now what we'll do is we'll add some elements to both these lists. I have two list implementations here, right? The linked list and the array list, right? So let's add some elements here. Let's say for I, I'm just putting a for loop. I'll go up till 10. Okay. So from 0 to 9, I'll be putting some data, and it will be the same index as itself, right? So I start at 0, right? So I'm going to say a list dot add I, okay, and I'm going to say a linked list dot add I. So what I'm doing is I'm adding all the indices that I'm iterating over, right? From 0 to 9, I'm adding all of them to the list. So this list will have elements 0 to 9. This list will also have the elements 0 to 9. Okay, both of them are now populated with some data. Okay, next step, what I'm going to do is I'm going to print out some of the methods that they implement, right? So let's do that. A list dot let's say a list dot get. Okay, I'll read the middle element. I'm going to get element at the index 5. So get of 5 will basically look at the index 5 in the list and try to get whatever value saved there. Same way, let me do the thing for linked list as well. Okay, likewise we'll have some more methods. A list dot get first, okay, and a linked list dot get first. Okay, same way, a list dot get last, and a linked list dot get last. Okay, so I have different variations, right? All of them are different implementations. Okay, when I say a list dot get, it's going to be the ArrayList implementation of this get method, which is there in the list, which is going to be this one. Let me take a look at. Sorry about this. It appears a little bit jumbled because I have zoomed the IntelliJ. This is the ArrayList. So you can see these many implementations are there for the get as well, right? So these many types of lists exist basically. These many implementations are there for list, but I'm just focusing on the main ones here that we use in day-to-day life. Okay, so let's take a look at the implementation of ArrayList, and if I look at it, yeah. So it just checks whether the given index is the proper one. That's, I'm not giving some index that is beyond the size of the list, and then it is going to return the element data which is present in that particular index. Okay, because this is an array of objects. When I remember what I mentioned before, right, in the last video, ArrayList is nothing but a dynamic array which keeps expanding based on the amount of data you feed into it. Okay, that's why it is internally having this array, right? It will fetch the element from that index that is present in the array. Okay, now that's the implementation for the ArrayList. Now if you look at the linked list, right, the same thing. If I want to take a look at the linked list implementation, if I scroll a little bit down, and here it is, a linked list. And linked list is also checking whether the index is proper. That's it sits within the realms of this thing. Okay, and then what it does is, where is that? Yeah, 1 minute. Let me go back to that. Yeah, and then it says node of index.item, right? Now what is this node of index? So node of index is basically, it is checking if for a given index, it, remember how nodes are linked list is saved internally in Java, right? I mentioned in the last video that they are connected as nodes or class node. This is how it will look like. It has a data, it has a pointer to the next node, it has a pointer to the previous node. So given the index that I want to get the data for, it will keep checking whether that node is reached or not. For example, it starts with the very beginning and then it checks what's the next one. So that will be the, so very beginning will be index 0, where node 0 will be there, and node.next will be index 1. Node.previous is null because there is nothing before the starting point, right? Node.next will be the next one, and likewise it will go on till the index that I want to search, right? I have given index 5 for example, so it will go from 0, 1, 2, 3, 4 and 5. So till that point it will keep checking node.next, and at the fifth element, right, in the array, which is the sixth element basically, because it starts from 0, 0, 1, 2, 3, 4, 5. So at that point, whatever node value is there, it is returned back to you. So that's how the linked list implements the get method. Okay, this is just one example I've given to show you how they differ in the implementations, right? And all of them will have the proper implementation, and everything will give you the same value as you expect. Now if I run this, everything that you see for the AList.get will be the ones that will be written by ALinkedList.get as well. Okay, see, let me bring this up. So the middle element was 5, so 5 was obtained, starting point was 0, last element was 9. Okay, now I'll show you the beauty with linked list alone. Okay, let's go ahead and change this to DQ. Why? Because linked list also implements the DQ interface, right, apart from the list. So I can create a DQ instance as well with help of a new linked list. Now what will happen down is, immediately the get of I is showing an error, right? Why? Because a double-ended queue cannot get the information from a random index. It has to get only the first element or the last element. Okay, because it's a queue operation, right? From the queue you cannot randomly pull something from the middle. The queue will process things either from the very beginning or from the last. So I don't even have a get of any index operation. All I will have is, if I say I have poll first or get first, I can have remove first, remove last, or completely remove. Okay, when I say dot remove, what it does is retrieves and removes the head of the queue, meaning the very beginning element, right? It gets removed. So there is no manipulation that you can do to something that sits in the middle when you have the DQ implementation. Okay, more about queues and DQs in the video dedicated for queues. There I can explain you a little more better, but just wanted to show you the difference, that the implementations that you use, right, they will vary, and one particular class can implement multiple interfaces, indirectly implementing the collections framework. Okay, so this might be a question to you guys in any of the interviews that you attend, like what is the internal implementation of a linked list? So a linked list follows both the implementation. It can have an implementation for the list, it can also have the implementation for a queue, right? But in general, if you look at the linked list, right, this is how the, so the remove is automatically throwing an error here. So I'll say get of 5 again, because I changed the implementation back to a list. It is expecting remove of some index that you want to give. So again, the index based operation starts, right? For a queue, there is no index based operation, right? So whenever someone asks you how a linked list is implemented, this is exactly how it's implemented internally. Okay, it has a current node and it has a pointer to the previous element and pointer to the next element, so that it keeps on linking the elements together. and how it is linked, or how you want to retrieve the data, how you want to manipulate the data, is basically what's determined by your interface which the linked list will implement, whether it's a list interface or it's a DQ interface. Okay, that's it for this video, guys. Thank you so much for all the support. Do hit the like button, subscribe to this channel if you like the videos that I'm putting out, share with your friends as much as possible, and I will see you guys in the next one, and we'll talk a lot more about the collections framework and the beauty of the different implementations of collections. Bye bye, guys.